Hi, I'm Alan White, Managing Director at Atlas Cables. I'm joined today by Kevin Kelly, our Engineering Director. And we're here today to talk about developments within the Atlas range this year. And we're going to be talking about three things specifically. We're going to be talking about advancements in our analog interconnects. We're going to be talking about our power cables and also headphone cables. So why don't we start with the analog interconnects, Kevin?
Yeah, absolutely.
So we are introducing a new technology called Duo.
Yes.
Can you tell us a little bit what that brings, please?
Yeah, I think before we talk about the latest thing, it's always good to go back and look at the start of the process. So, because it's quite useful for viewers to understand the context of a new development. So, in analog interconnects, the people talk about topologies, but what they're really talking about is how is the cable constructed, right? So if you actually go and you go to the hi-fi market and you go and look at analog cables, primarily the entry level products I've got a topology or a configuration called coaxial, right? So basically what that is, it's a signal conductor, and on that signal, that's again where the information flows, and on the screen of the cable, which is the outer of the cable, that is where what they call the return signal goes. It's a bit like a battery. It's a positive and minus. Electrons go from the positive, flow to the negative. Right. So why is that type of topology likely used a lot? And that is because it's popular because of two things. It is quite accurate, right? It gives a certain amount of screening, but it's a low cost way of producing cables. So a lot of cables, when you go to the market, consumers quite a lot of the times ask why is our cables at £100 and why is our cables at thousands of pounds, and generally speaking it does come down to this topology, right? So a coaxial cable signal as a signal and as a return conductor. Now the Atlas, if you go one step above that, Atlas's preferred topology is a cable, is a balanced cable, right? So it has the same identical structure on the signal as in the conductor. So if you think about that as over a coaxial cable, there's twice as much material in one as the other, right? And having the same conductor on the signal as on the conductor gives a fidelity improvement immediately to the product. So if we're developing a product, simply by that single choice, is it a coaxial or is it a balanced cable, we immediately know whereabouts the performance is going to sit, the kind of median performance. Now, when you have a balanced cable, it really has three components. It's got a signal, it's got a return conductor, and it's got a screen. And previously, in the previous 20 years at Atlas, when we used this type of topology in an RCA cable, we implemented a thing called pseudo-balanced. So basically what you did was you took the screen of the cable and you connected it to the return conductor at one end, right? And what this did is it gave you the advantages of balanced in an RCA, and it gave you a greater form of screening, right? And again, if you did a demo, give an example in the Atlas range between an element achromatic RCA, which is a coaxial cable, and the previous version of Hyper, you would have had an immediate difference in sound quality. And a lot of that would be to do with how the cable construction, how its topology is created. So one of the I'm a great advocate of attention to detail and small gains making cumulatively adding up to give you a big advantage. So maybe about 2 or 3 years ago, we took the pseudo-balanced RCA topology a little bit further, And what we did was we effectively broke the link between the screen and the return conductor and the cable, and we took it outside. And many Atlas customers now know this is a system called GRUN. All right, it's an external grounding system, and so the cable didn't change, the materials didn't change, the plug topology didn't change, but simply by taking the screening outside and allowing you to connect the screen of the cable directly to a known earth point, it allows you to drain any external noise directly from the cable, directly away from your system. And that drops the noise floor, and that gain for the end user, for listening to it, just the fidelity just jumps up. You know, things become more natural, more accurate, more open, and the whole soundstage just opens up. So when we set out in this new range of development analog interconnect, we wanted to see if could we take that a little bit further. So we took the balanced topology and we thought, well, how could we make that? How could we take that even further? So what we developed is a new topology called Duo, and what this does is it takes the signal and the return conductor, and instead of enclosing them, encasing them in a single screen, we have a separate screen around each of these conductors. Right? So we now take that and these two screens external to the cable, and we attach it to GRUN. So we get an incremental increase in the effectiveness of the screening of the cable, and again for our customers, that gives them greater fidelity, and that's the essence of what we believe is the hi-fi world is about, is how do you continually improve your products and deliver better fidelity for your customers.
You've mentioned screening a fair bit being important. Could you talk through why screening is important for something like an analog interconnect?
Yeah, screening is I mean, if we had this discussion, 15 years ago, it would likely have been a bit easier, in the sense that the world was still very much analog. Hi-fi was much an analog world. However, in the preceding 15, in fact maybe 20 years, we've seen far more digital devices coming into the hi-fi world. And when you have, suddenly you're getting routers and switches coming into your hi-fi system, then the need to screen the sensitive analog parts of your system demands become more and more. So screening is the attempt, as an engineering term, to try and keep unwanted signals or unwanted noise away from precious signals, right? And that basically is, if you can keep the dynamic range high, then fidelity improves, sound quality improves, soundstage enjoyment improves. So screening is a key element of what every single system does. And screening, again, used to be, if you're a product designer, an electronic product designer, then that's a critical part of your design philosophy. It's a critical part of the certification as well, that your products don't emit RF information and also are not susceptible to it. But in cables, you think it's less so. But however, cables are the conduit. They're the links between areas. And we all know that wherever we are in life, the links between things are often the places where things fall down, and error creeps in. So by having screening, improved look at screening, what you're doing is you're protecting that precious signal integrity which you need for all forms of high fidelity.
Got you. So Duo as a new technology is being implemented in the Atlas range.
Yeah.
So we've got quite a broad range of products, all the way from Element all the way up. Where does Duo fit into the spectrum?
Well, as you know, we've got three kind of families of product, or three categories, and the Duo fits into the Aspire range of product. And within the Aspire range, we have two families. We have the Ailsa product, and we also have a Hyper product. So we take the Duo, which is this independent screening of the signal and return, and we decided to apply that across effectively three different product areas in the Ailsa range. So we've developed a new product called the Ailsa Duo Ultra L Grun. It's a bit of a mouthful, but each of these elements tell you a bit more about the product. We also have developed an Ailsa Duo OCC XLR, and we also have, for those name fans out there, we've got an Ailsa Duo DIN versions, so we cover all the DIN versions for lots of those good name customers out there. So if we go and look at maybe the Ailsa Duo, the RCA first, the Ailsa Duo Ultra has got all the components that we believe are cutting edge. So we've got a new topology for the cable itself. The conductors are produced from OCC copper, which is again our preferred material. We have a foamed polyethylene dielectric, which is basically it's a dielectric that has got nitrogen foaming in it, which traps air, and effectively it improves the bandwidth of the cable. So we've got the conductors. We then fit the latest ultra lattice plug. So this is a plug development that we've been developing for 10 years or more in its latest incarnation. It's a 3D printed, state-of-the-art RCA cold welded plug. We've put that on the product, and of course, as mentioned earlier, the third connection on these cables are the ground connection. So if I maybe show you the Ailsa here, you can see here maybe you can see why it's called Duo, because you can see externally that both the signal and the conductor here have a separate cable, and this is a screened cable. They're combined in the plug, so into its signal and return. The lattice plug, although this part, the metallic part, the outside, is there for is twofold. It's there to control the expansion of the inner part. So the inner part's a 3D molded part. So we choose it for its electrical characteristics, for being wideband, being fidelity. But one of the things that you need to take care of when you use any molded 3D printed part is its temperature stability. So the outer part here controls the expansion of the plug internals on a horizontal and in a cylindrical basis here. So it stops the plug becoming, it maintains the tightness of the plug in the connection, irrespective of what the temperature is in the equipment or in the room. And we can also see here is that, and as you mentioned earlier for screening, this is the grun connection. And when you remove the dust cover from the end here, what you also get within the cable itself is you get a grun cable, and this grun cable connects here, and then it connects onto either a chassis stud on your preamplifier, or you have purchased a grun power adapter from Atlas and you connect it directly up. So the cable has all the state-of-the-art elements that are likely available currently in our Aron, Asimi and Mavros range of products. So it's a real top performing product in all senses.
So going from the Aspire range originally, with Hyper and Ailsa being the products within that, we see this as a real step up in performance versus what's currently out there.
Absolutely, it's when we carry out the demonstration to prove the technology, we are very keen to make sure that when we do launch a product, then it's not just a me too. The product has to have value and it has to offer the upgrade possibility for previous customers. And when we do the demo of the existing Ailsa product against the new Ailsa Duo, then we believe it's a significant improvement, and it's certainly one that you would certainly go in addition at your local retailer.
Great. Finally, how would you categorise better performance in a cable? There's obviously a lot of superlatives and whatnot that's used out there in the markets with cables, but I know that the Atlas philosophy, and one of the things that I really enjoy, is that we're an engineering company first and foremost, and therefore we don't come out with this is going to do this to your music, that to your music, and we're a bit more. It might sound more humble in many ways, but actually we're trying to reduce signal loss between point A and point B. And so what is a performance cable look like to you? If you could put it into a few words, how would you describe that?
Yeah, well, I can only relate it back to kind of reality that I'm a musician. I play live music every week. I'm a brass player, so I go to band practice twice a week. Have done for 54 years now, and maybe an analogy that I often use, but it keeps coming back to me all the time, is that we get and we play collectively as 25 of us for half an hour. After half an hour, the conductor comes in, he does a tune-up, and it goes along. 50 years ago they did it by ear, then they did it mechanical tuner. Now it's get their phone out and there's an app and it does a tuning app. So they tune the absolute pitch and relative pitch between all the notes. They go along, maybe 4 people, somebody's flat, somebody's sharp, whatever else, pull it in, pull it out. Now the machine says, all 4 sounds are identical. But at the end of that process, if we had a vote, and the other 20 members of the band, which one sounded the best, then I'm certain that 95% would pick one. And it's that whole thing about the human, the limbic area, your brain, is that better sounds better to everybody, and it makes it easier to listen to. All right, maybe the technical words we use with Atlas is it's more accurate, more open, and more natural sounding. And the more accurate and the more open and the more natural sounding the cable, the more enjoyment you get for your system. So I would say that it's the better, when we lose less, the system just sounds so much easier to listen to, so much enjoyable, and you get so much pleasure from it.
Wonderful. Thank you very much.